Welcome back, everyone. And it is my privilege to introduce our next speaker, Dr. Tom, who is going to give a presentation on Escape the Python.
Thanks, everyone. Hi. Cheers. My name is Tom Allen. I'm a software engineer, robotics engineer, and these days, game designer. I'm not quite sure how my career ended up here, but it did, and I'm going to talk to you about a project that miraculously has kept running for about 10 years. Cubescape is a tiny company that I helped found about 11 years ago now. We're based in Melbourne, actually about 1 kilometre away in Collingwood, and we design, build, and operate escape rooms. Our rooms are full of technology. They're basically robotics systems that we put people inside of, and they get to explore an environment. Can I just get some hands up? Who here has played an escape room? Okay, cool. I don't need to do that explanation. For the few of you who haven't, they're basically an entertainment experience. You get locked in a room. We don't actually lock you in. Don't worry, it's safe. You get locked in a room for about an hour, and you experience a story and have to solve puzzles and work with your teammates to escape. So our systems are built across a network of Raspberry Pis, all running a lot of Python code with a very heavy dose of async I/O. But we started writing this stuff in 2014 with Python 3.3 and Debian 8, and a lot has changed in 10 years. But weirdly, our code hasn't changed all that much. Our earliest escape room running in Melbourne Central is still running, literally the same code today. So this talk's going to dive into our architecture a little bit to show how and why we did things the way we did. And at the end, I've got a few lessons learned on what it takes to keep something running for 10 years. So I'll start with what is Cubescape, then talk about why we picked Python. We'll go briefly into our architecture. It actually gets quite complicated, and I'm going to stay at the high level. Then I want to talk about some things that in Python, or in the Python ecosystem, that bring us joy. And if you don't know about these things, maybe you should go research them, and they might be applicable to you. And finally, I'll end with those lessons. But first up, we build cool stuff. So I want to show some pictures of the kind of stuff we build. So we're an escape room company. We make immersive experiences. These are experiences that make people gasp, that make them laugh, that sometimes make them a little bit scared. We let them experience new worlds, or maybe a familiar world. We make tools for our business-to-business customers to actually run and operate their rooms, and we also make the rooms themselves. We started from pretty humble beginnings, and now we wrap a lot of technology. All of that is literally to make these 4 pictures fall off the wall when a ghost screams at you. It's quite a lot of complexity. But we wrap this technology behind a beautiful facade. Well, we like to think it's beautiful. There's a lot of fabrication and machining and manufacturing that goes into this, but we think the results look pretty damn cool. We make a lot of complicated gizmos. This is a crack in the wall when you find the missing piece and put it in there, an RFID system goes, oh, yep, that's the right piece in the right orientation, cool, success, puzzle solved, things like that. We use a lot of smoke and mirrors, literally. That is a smoke dissipation pipe with a whole bunch of actuated vents that send smoke into different places. That is a gearing system for moving a mirror. We also build sometimes wireless self-contained props. This is an alien DNA analyzer that you have to pick up and move across the room. And sometimes we make very, very wired props. It looks very dangerous, but I assure you actually there's a Raspberry Pi hidden behind the back of that, and it's perfectly safe. We also get to build spaceships, which are pretty cool. And these spaceships sometimes have alien egg incubators in them. And then we get to build science laboratories. And then we get to crash those spaceships into the science laboratory. So in short, we've been making cool things for quite a while. We started in 2014. We literally went and played an escape room, and we thought, we could do better than this. And then we did. So we built a just-for-fun room, literally because my co-founder wanted some more warehouse space to build stuff. And he bought a warehouse, rented a warehouse. We had the room. We thought, let's build an escape room in it. That'll be fun. And then in 2015, people liked it. So we weren't really selling tickets. We were just taking friends and family and anyone who wanted to go through it. But in my other hat, I do game design, board games mostly. And I met some people at the Penny Arcade Expo, PAX, which is on soon in October, who ran escape rooms. They were from Strike Bowling, or their parent company, FunLab. And we shook hands, we invited them to come play our room, they loved it, and then they agreed to buy it. So we sold it to them, and we moved it to Strike in Melbourne Central, and called it Shutdown, and it is still running 9.5 years later. In 27, yeah, thank you. By 2017, we had 5 rooms open in 4 locations across 2 states. By 2018, we had 13 in 6 locations in 3 states. In 2019, we went, whoa, wow, we're doing well at this, we should open our own room. In 2020, we don't really talk about that very much, but we did survive, and by 2022, our room, which is called the Curium Experience in Collingwood, it won the only award for any room in the Southern Hemisphere. We like to think we've got one of the best rooms in the world. I really do think we do. From 2023, well, a noisy workshop. We've been building our 2nd and 3rd rooms concurrently. Our 2nd room, hopefully, we should open this year. And in 2025, I didn't do much of an intro of myself, but I'm effectively a freelance engineer at the moment, and that's a long story for another talk, but it has its ups and downs. This year's been a bit of a down, so I've had some free time. So I went back and did a major overhaul of a lot of our software that I've been wanting to do for 10 years, and now, although the software at its core is still the same, I've been able to upgrade to Raspberry Pi 5s, Python 3.11, or 12 even, Debian 12, and we now run multiple games within the one venue, and so our architecture has stood the test of time. We've evolved it, but at its core, it's still the same thing, which I'll get to in a minute. I probably should have led with this, but at this point, we've now had more than 500,000 players through our rooms, and they've generated over $15 million in revenue, which I think is pretty good. So why did we choose Python for escape rooms? There's a bunch of different mixed up reasons in here, but we did look at existing frameworks that we thought could achieve this. Basically what we need to do is event-driven control of things. We've got players walking around the rooms, opening cupboards, looking in things, plugging things in, turning switches. We need to listen to all of those events and process them in some way to trigger other things. We looked at frameworks like Node-RED or Home Assistant, but at the time they didn't support DMX, which is a multimedia standard for running lights and sound effects. We knew our rooms were going to involve that. And so because they didn't do that, we looked at other things. We also have physically separated environments. Almost every escape room has a big reveal in the middle where the players go, wow, we've kind of done everything here. Oh my goodness, there's a secret door, and look, there's a whole new space to explore. That kind of reveal is really stimulating for players, and so almost every room is going to have that at some point, which means you have physically disparate spaces, which means you probably don't want really long wires going everywhere, and you probably want multiple computing pieces to plug into stuff. So we needed multiple cheap computers, maybe Arduinos, maybe Raspberry Pis, maybe Intel NUCs. We looked into all of that sort of stuff. We also realized, though, that a lot of the gameplay is highly interactive. We've got a science fiction room where you are mucking around with an alien interface and turning knobs and things, and there's this high-tech GUI-looking thing. It's very nice if you can write that GUI in a complementary language to whatever you're writing everything else in. Python, and we use PyQt, it works really nicely for that. So in the end, we realized that Raspberry Pis did meet the brief. Raspberry Pi 3s were $25 a pop when we started using them. Now, admittedly, we pack a lot more electronics into our own custom board behind that, and so we're probably getting up to $200 per compute at this point, but it's still pretty cheap. I also had a working knowledge of Python, and I had a major headache from trying to write a game in JavaScript, so I knew I didn't want to use JavaScript if I could get away with it. And the other big thing, which I think is a real selling point of this ecosystem that we're all part of, is that every time we look to see if something was supported in Python, there was a library. There just always is. Almost everything I've ever wanted to do, Python can do it, with sometimes more or less of a fight than other times, but it's all there. They really say batteries included, and a lot of it is. So I'll now go very briefly to our architecture, which looks a bit like this in simplified form. It's pretty standard for this kind of thing. It's a single server, multiple clients. So that server processes something that we call AutoScript, which I'll touch on a little bit later. That's a domain-specific language we've written to explain how the story should progress and what things in the room can trigger various events in that story. Each of the clients handles a logical or physical section of the game. For example, we might have a node running a client that does all of the first room's props and all of the sound effects for everything. And we might have another one that's, actually this desk over here is very complicated and it's got these lockers and things around it and a GUI, so we'll have one client for that. We can run multiple clients on a single computer. It just can get a bit messy with cables going everywhere. So because we have this architecture, we can very easily go, actually, it'd be nice to have that on a separate machine over there. Broadly speaking, the server talks to and listens to clients, and we have another type of client called a director, which is what our game masters use to operate things in the room manually when they have to, or to provide the kind of voice of God to give hints to the users. Clients then run sort of three sorts of things. They receive inputs. I've colored those in orange because it's more or less hardware. They do processes, which are more software-related things, hence green, and they trigger outputs. So those inputs are sensors and controls. We use a lot of read switches. Every time someone opens a door, we know which door's opened. We've got RFIDs, we've got magnetic card readers, we've got keyboards, touch screens, swipe cards, all sorts of stuff. We have a lot of controls, kind of covered in that same area. And then for outputs, there's a lot of displays. There's a lot of controls that go through various industry protocols like MIDI or DMX or Modbus for controlling lights and smoke machines and the HVAC of our venue. And a lot of actuators. Again, smoke machines, lasers, things that look like they're going to be saw blades, like all sorts of crazy stuff. Lots of motors. One of our rooms has got some robotic arms that players get to control. All of that sort of stuff we wrap up in a driver, which is really a piece of Python code around a library that does the thing we really need it to do. Now, over time, this architecture has evolved, but it has broadly stayed the same. That simple client-server TCP/IP stuff has all stood the test of time. One interesting thing that happened, though, was we sold some rooms to Strike where they wanted 4 rooms, and we really only had 3 games. So what they proposed was that we do 2 copies of the same game, and we build in a competition mode, where you could have 2 teams playing the same room simultaneously, and whoever finished a puzzle first would have some kind of influence on the other room. And we did that by building these bridge receiver and bridge sender ideas at the bottom, which really just open up another TCP/IP client-socket relationship, and they're in a kind of crossover formation. So room 1 can send to the receiver of room 2, and vice versa. And we could have done that with a director at the top, and in fact we did. But by doing it this way with drivers down there, we ended up with a technique where the receivers would just validate messages and then forward them onto their server exactly like any other piece of equipment in the room. And by building it all into effectively the same architecture, we baked in a lot of extensibility without really changing how our server does any of its processing. And that has paid dividends, because our architecture now looks more like this. We now run a venue with what we call pipelined games. We can push multiple teams through a single game without them ever clashing into each other. And you might think, well, hang on, what happens if a really fast team catches up with a really slow team? We've thought that through. We can measure their expected performance versus their actual performance. We can add in additional content to slow them down. We can remove content seamlessly without players noticing, so that all of our teams get through our game in 59 to 60 minutes, very precisely, and they all have a really exciting experience. They all think they won, and you just may see more or less content depending on how good you are. As a result of that, well, thank you. So we are strong believers that the experience is what matters. It doesn't matter whether you solve everything. It matters that you come out feeling like you had a good time. So we really strongly focus on that. And just to appease any purists in the room who think that this isn't automatable, we do also have game masters watching, and we make sure that they intervene when needed to make sure everyone has fun. So broadly, this architecture now, it is the same, but every room has these bridges to do communication between rooms. And so as a result, our venue is a game. Our games are now 3 games, staggered, and they all communicate with each other to make sure that this pipeline of teams playing through all works seamlessly. So I think that's enough on the architecture, but I will absolutely take questions on it if people are interested. What I wanted to talk now about is some things that we use that are in the Python ecosystem that we think are really interesting and have paid dividends for us. One of them is PyParsing. So I mentioned before we have a domain-specific language that we call AutoScript. It really has two core concepts, story points and objects. Story points are like a gameplay moment, like the big bad guy reveals its lair, and they can be triggered directly, or they can follow a combination of events from other story points or from objects. And objects then represent the physical or logical things in the room, like the exit door or the lights. So we can very easily write something that says, when the exit door opens, turn on the lights and play the credits, things like that. So that piece of code there is roughly the kind of syntax you end up writing in PyParsing. It is reverse Bacchus-Naur form, if anyone's familiar with that kind of thing from writing parsers. PyParsing is a pretty good implementation of a way to write parsers. And to prove just how useful this has become for us, our Python code is really only about 30,000 lines of code. It's not an enormous system, but we've now written over 200,000 lines of our AutoScript. So we use that everywhere. Another thing that we built upon heavily is asyncio. So I mentioned that players in an escape room, it really is a multiplayer, event-driven architecture. And asyncio, for those who aren't familiar with it, is now baked into Python. When you write async def or yield from, you're using asyncio. But when we started this game, we were in Python 3.3, we didn't have that yet. You had to import asyncio and set up your event loops and poke events into them. And it was a bit messy, but it worked. And that library has definitely proved its worth. It's now part of the language inbuilt. It basically gives you event-driven, thread-safe capability for very little mental effort. The brilliant thing about that is you don't need to think about semaphores and mutexes and making sure that people don't access this resource simultaneously, because they can't. There's an event loop. Only one thing is actually happening at a time. It just time slices it, so you think it's all happening simultaneously. It's a very useful technique if you're not familiar with it. Have a look. For us, we pretty much just send blobs of JSON over the network. And because it's a local network, that's fast enough for us. You can, of course, send byte streams in the same way. And sorry, AIO HTTP is the async IO HTTP library that we built upon, which provides this client-server architecture quite neatly. And having an event loop also helps when we do have certain high latency responses. There are a couple of things we do where we call out to the internet, or we call out to a slow RFID reader that needs to be polled over the course of a second, things like that. So when we're I/O bound, the event loop again is kind of taking care of that for us. Another thing we love and we use a lot of is PyQt. Specifically, we use PyQt 5, but I've tried PyQt 6 as well, and it's got some extra bits that are quite useful. We have used that for basically all of our tooling GUIs for many, many years. And by tooling GUIs, I mean kind of this bottom right thing, for example. That's a GUI that our external venues will use to manage their rooms. If they need to reset a room, or they want to associate player data with the room, or they want to print out reports at the end of a play, and we track a lot of statistics about what players do, and we can give them a score sheet. It tells them how well they've done and how fast they did things. We also use PyQt for all of our internal GUIs. We basically turn the Raspberry Pi into more or less kiosk mode. So we're suppressing things like Control-Alt-Delete so the players can't muck around too much. And we pretty much just hide and show layers as needed. So we'll have a layer with a video on it, and we'll hide it when the video doesn't need to play, and we'll pull it into the foreground when we need to. Eventually, though, we realized that that was so flexible, and we were so familiar with our AutoScript library that we actually started writing our own internal tools this way. So we now have like a wireless GUI for what we call our gophers, who run around resetting rooms. It shows them what room needs to be reset, the estimated time before someone's going to be in it, and so they can muck around and do all of that, and it is just one of our clients running on a wireless PC. There is some fiddly magic to juggle the Qt event loop versus the async IO event loop. That was hard to solve, but once I've done it, it's worked for 10 years. If anyone is interested in how I do that, I'll go into it, but I think for the average audience, it's probably a little weird. Another thing I really liked is PyInstaller. PyInstaller is a way of packaging your Python application into something you can give to someone else so that they can run on their computer. And although this is not the modern software approach, old people like me, and I'm not that old, but I feel it these days, they like just being able to take an exe file or a Mac app and double-click it, and it runs. I don't want to fiddle with registries. I don't want to sign my software. I just want you to give me a USB stick with something on it, and I can run it. That's cool. Pi installer has this beautiful flag called 1dir, which does exactly that. It puts your Python executable into a folder or an exe, including Python, the runtime, and including all the libraries that you've baked in, and it gives you just a one-click app. Nothing to install. That's been very useful to us. So whenever we've needed to give an external client something that they can control their rooms with, we can give them a GUI instead of a bunch of scripts and pads of paper. Similarly, yeah, we can do it for Windows as well. One note I would make on this, it is cross-platform in the sense that you can build executables that run on multiple machines. You do need to run it on the operating system that you want to use it on. You can't cross-compile from Mac to Windows. But still, it's an incredibly valuable tool. So I'll kind of start wrapping up at this point with some challenges that we've had over the decade. I think the biggest one was not knowing that it was going to last a decade. There are certainly things we would have done differently. I realize I'm running out of time, so I'm going to skim through some of these and get to the lessons instead. One other challenge is the hesitation to push back the trunk when your customers are miles away. One of our sites is in Surfers Paradise, right? It's 2,500 kilometers away. If something breaks there, I don't want to have to fly there. So it has led to not wanting to change things. And that's dangerous, and I've got some lessons on maybe how to fix that. Another problem is that third-party code never shared our philosophy of if it ain't broke, don't fix it. And we often got to that question of, do we patch this? Like, it's not that valuable. Do we just leave it? It's led to some problems. So the lessons that I think I've learned from running something for this long are, I'm phrasing these as almost tweaks to cliches that you will have heard. You don't necessarily have to keep things simple, but you have to keep them understandable. Making sure that you know what you did 10 years ago is important. So write good comments. If something's complicated, break it up, abstract it, put it in black boxes, all of those tips and tricks. We've slightly changed our philosophy, and I think this is the biggest lesson I've learned. If it ain't broke, maybe fix it anyway. Because over 10 years, if you don't fix it, when you have to, it's hard. But if you do perpetually keep incrementally patching and upgrading, it's not so hard. And I think that is a lesson that I personally have learned, and I think it's one that, in some situations, is valuable for others to take away. I also invert Facebook's philosophy. I don't think you should move fast and break things, especially when customers are relying on your code to work for them. If you break their product, whoops, that's weird. If you break their product, they're going to be grumpy. So maybe move a bit slower and don't break things. I also feel it's valuable to do it yourself for the simple things. The canonical example is left pad. Don't rely on a library for padding things to the left. Just build it yourself. It's probably 5 lines of code. A lot of little simple things like that. We put in a utilities class. We write them once. We test them. They work. We never have to look at them again. We don't rely on anybody else for that stuff. And another one I've learned is probably going against the Pythonistic paradigms, but I think a try, catch everything can absolutely save your bacon. We want this code to run for 24 hours without crashing, and being able to catch anything that randomly turns up at runtime is really helpful. And finally, if you are going to last this long, celebrate your wins. This video is literally the very first time I ever got AutoScript parsing, and I still look at it and see the excitement in my face.
What are you doing, Dave?
Okay. Very good.
Cool. I'll leave it there. Thank you for listening, everyone. Oops. Sorry. I was trying to skip to the next slide, but now it doesn't want to do it. There we go. Thank you for listening, everyone. Cheers.
Thank you, Dr. Tom. That was very exciting and thrilling. And we now have time for questions. Yes?
Thanks for the great talk. Escape rooms are known for being extraordinarily hard-wearing places. Could you talk a little bit about the challenges involved in keeping quite a complex sort of technology suite working in a hostile environment?
Yeah, that's absolutely true. So a lot of our users, especially when we started selling games to Strike, are frankly young, drunk people. playing games. Basically, the way we protect everything is that nothing wired is in front of users. It's all behind a cabinet with hex screws that you need to unscrew to go and fix it. So that means the technicians can get to it, but the players can't. We also, for our wireless props, we spent a lot of time throwing them at the ground and making sure that you couldn't crack them open. For our GUIs, we tested every keystroke I could think of under the sun to prevent players from getting out to a terminal and being able to muck around with stuff. We hardened our client-server architecture, so if someone did manage to get on the network and sent things in, there's a hidden secret key that you need to encode everything with. There's a CRC on the stuff. We did put a lot of thought into that, but in practice, most players aren't there to be malicious. They're just clumsy. So if you protect against the obvious things, you've covered 99% of the battle.
Yeah. Next question, please.
So thank you for the great talk. And so a question about PyQt. I've used PyQt for widget-based desktop apps, but what I would go to for making a sort of bespoke UI that runs on a Raspberry Pi, what I would usually go to is Pygame. Have you looked at it all? Any comparison?
Yeah, so I did actually use Pygame right at the very start. We wrote some GUIs in that. I'm not 100% remembering why we gave up on it, but we did find that PyQt had a lot more inbuilt features. You want to display a video, there's a widget for that. You want to drop a picture on a label that used to display text and have it display the picture, well, the label driver does that. So it had a lot of more stuff out of the box. And I think also the layering was easier to use. Instead of just relying on a Z order, you had hide and show and other things. So it just had a bit more out of the box that we worked with. Yeah.
And question from Paul.
Hey, it always seems to me that the designers of escape rooms must be learning and going to all of the other escape rooms and seeing what's cool, what's new. And I'm kind of wondering, is there a community of people that are building escape rooms that are sharing ideas? And secondly, does that kind of flow into open source? Do people share their code as well?
Look, that's an interesting one. I haven't seen a great deal of open source escape room code. We did think about open sourcing ours or even trying to license it. Maybe people want to buy our tech. We realized it is pretty fiddly. Right? You need to have a software knowledge to get it going. Some of those other frameworks like Node-RED, they are really drag and drop, no code. So they're much easier to get going, but they do have their limitations. We like to think that we probably put more investment into our escape rooms, and as a result, we've got very high quality ones, but we spend a lot more on them. So there's a trade-off there. The other side of it is, yeah, there's absolutely a huge community of escape room owners, and we all talk and share things. It's a very friendly community, and the main reason for that is that we're all supply limited. Right? We literally can only host 30,000 customers a year, no matter what. So it doesn't matter if we kind of recommend our friends and we say, you've played our rooms, well, you probably aren't going to play it again. It's going to be the same. So go and try these ones and these ones and these ones. As a result, the community is great and very, very open to sharing things.
And a question from the gentleman with the Nginx shirt.
Yep. So how do you deal with hardware being unreliable? Like if you had something that, say, unlatches a door and the door doesn't unlatch, do you have feedback to that or alerting or?
Yep. Yeah, so I guess there's two answers to that. One thing on hardware being unreliable, well, we test the heck out of it and we select things that are going to be rigorous. We do also have game masters in the loop. I have to admit that our third-party clients don't always have as high attention game masters as we do ourselves, so things can fail. Our software has failure mode detections and circumventions in it, so if something doesn't respond the right way and we do have a sensor loop on that, we can often bypass it and literally change the game so that instead of that door activating when you press a button, oh, the button's failed? Okay, the door's going to activate on a timer now instead. So our code has those kind of capabilities. Sorry, there was a second part to your question around the rigors of the hardware, and I've lost it. Can you say the second part again? Alerting. Yeah, so we do also have a lot of logging and a lot of back-to-base logging, so we can hook that up over the internet and fire it in real time. So we have a Slack app that beeps at us if something goes wrong. Yeah, there's a lot of bits and pieces to it, so we cover it.
Any further questions?
I was just going to ask about the database and storage. What kind of database is backing this platform?
Honestly, nothing. There isn't one. There's not a lot of data that we need to persist. So a lot of our nodes will just dump logs to text files, and then we tar those up and we ship them back to ourselves. And so we have some scripts that will analyze them, but there's not a lot of need for a database. There are a couple of exceptions to that, and so there are some little mini databases running there, but honestly, SQLite has been fine for a lot of what we do. Yeah.
Well, that's that. Thank you very much for that exciting talk. Now, I'm supposed to just give you this mug, but I am tempted to lock it in a safe with a combination that requires permutations of prime numbers and pi to 5 decimal places.
Well, fortunately, I've got an AI on here, and I'll just ask it.
But thank you
very much.
Another
Appreciate
round of
it. Cheers.
applause, please.
Thank you.